past 5 companies have been developer focused. If you have any discussion items you want to talk to me about any of those companies or something you want to hear about from my talk today, feel free to follow me on Twitter. You can see my Twitter handle right there underneath my photo. It's at Kunal732. It's just my name and then the area code where I grew up in, Kunal732. Also, last night, I think everyone here was maybe a little disappointed with Game of Thrones, but I just saw the best trailer for Westworld Season 3, and it was amazing. So I definitely recommend everyone here to watch that trailer if you're into sci-fi like me and AI. It's pretty cool, so definitely recommend it. All right, so a little bit about our agenda today. We're going to start off with a little bit of a history and overview of AI. This is going to be a concise history. It's a really big topic with a lot of different events. I'm going to pick the ones that I thought were really cool and important. We're going to go from there, talk a little bit about different types of deep learning, and then go into computer vision and kind of break down some important types of computer vision. And then the fun stuff. We're going to create an image classification application. This is an introductory talk, so I'm not going to go over all the details, but I really want to give you the experience I would have wanted when I was in my undergrad learning about machine learning and computer vision with actually seeing code. Oh, and this is a YouTube video. I don't know if you guys can take a photo of this or not, but this video came out in 2008. The person speaking is Jeff Hawkins. He founded Palm Computers, if you guys are familiar with that. This talk really inspired me to get started in computer vision back in 2008. So I don't know if you can see the name. It's really small in this image. So you can zoom in. It's called Jeff Hawkins on Artificial Intelligence. Such a great video, and he's such a good speaker. If you want to learn more about the topic, I highly recommend that you follow this on, watch this on YouTube. Okay, so let's get started. And like I mentioned, this is a concise history on AI. So for this history, let's rewind back to the 1930s, specifically 1937 with Alan Turing. I feel like people here have heard of Alan Turing maybe, the Turing test. But if you haven't, in the 1930s, actually 1937, which was 10 years before the first digital computer, Alan Turing created this paper. And he wanted to really move the discussion on algorithmic thought. And he created this conceptual machine called a Turing machine. And he came up with this thought experiment, this thought machine, where essentially it was a paper tape. And you can kind of get an idea of how that paper tape looks like, but it's a paper tape, and it's divided into even squares. And he had this idea that this paper tape on these squares can have any symbols written on it. And then the second component of this Turing machine, there was this box that could read or write any element on this paper tape, and it could also move up or down one level. And then in this paper, he showed that this Turing machine can turn into a universal machine. It can mimic any other machine. It ended up that this was actually pretty prophetic, and the paper tape is analogous to linear storage. The box is analogous to a CPU. And again, this is 10 years before the first digital computer where he thought about this. He said that this was, again, can mimic any sort of machine. And I really feel like that's the starting point for AI from the way I've seen it. Now, move on a couple of years to the 1940s, and we started understanding, have a better understanding of how our brains work and how neurons in our brains work. And that's when around the first neural network was created. So let me see if I can zoom in on this image over here, because I feel like it's a little small. So on the top over here, you can see how neurons work in our brain. You see, oh, can you not see it? Oh. Is that a little better? Okay, so right over here, there we go. That's a neuron in our brains. You can see that there are different components to it. There's the dendrites, the cell body, the axons, and this was the first inspiration for a neural network. This was created in the 1940s. On the bottom, you can see the computer version of this, which is essentially a node with edges. And each of these edges have weights on them, and when they hit the node has a function, and if the numbers hit a certain value, the function will then output another value, and this mimics how neurons work in our head. So this first came out in the 1940s, and then in the 1950s, something got created, which was the perceptron, which was the first self-learning neural network. So no longer did data scientists at the time have to manually put in values to mimic this human brain cell. It was now learning by itself, but it was really basic, really bare. There was hardly any computing power at the time. This perceptron led into the development, eventually the development of something called backpropagation, which is how a lot of our machine learning algorithms are trained right now. Backpropagation came about in the 1980s, actually. And it was showcased how you can train neural networks. However, nothing really happened in the 1980s. There was no renaissance of AI, and we realized that there was two key missing components missing at the time. The two components are GPU technology. We didn't have fast enough processors, and we also didn't have data sets. The internet really helped us create these big, vast data sets that we can use to train these networks. So starting in 2012 with the advent of all these GPUs and higher computing power, that's when we really saw a renaissance in AI, and that leads us to a little bit of where we are today. Now, some terminology that you and there are different types of machine learning. The three most popular types I would say right now are supervised, unsupervised, and reinforcement learning. Reinforcement learning is kind of like how we learn. It's through the consequences of our actions in an environment. If something's good, we get reinforced and we know that keep performing that action. If something's bad, we don't get a reward, we don't perform that action anymore. You also see this used a lot with pets as well. Supervised learning is what we're going to be doing for our image classification algorithm at the second half of this talk. But essentially, you give a machine, artificial network, labeled data, and it knows how to learn from that labeled data. Unsupervised learning now means there's no labels. It just learns from the actual features of the inputs you give it. And so, now going from here into computer vision, there are multiple different types of computer vision algorithms. Image classification for me is one of my favorites, and that's again what we're going to be doing later today. But essentially, image classification algorithms can take a look at an image, and from there, the computer can let you know what it sees in that image. It won't let you know where in that image it sees it, but it can find out what different labels are in this image. And in this case over here, you can see a screenshot from one of our services, AWS Recognition, having given a screenshot of, looks like New York City right now, the skyline, and from there it's saying it sees city, urban, town, building, metropolis, high-rise, right? It doesn't tell you where it sees these items, it just knows that it's seeing it, and again, that's image classification. Now there's two really big use cases for image classification that we see a lot of businesses use today. That's going to be moderation, so whether an image is safe for work, not safe for work, and also organization. If you have a large set of images, image classification can give you tags to organize and search on those images, and that tends to be the two biggest use cases businesses use for image classification. Now detection goes one level deeper. Not only does it tell you what is in an image, it tells you where it's in the image as well. And when I was preparing this talk, I saw a great video. I believe it was at reInvent, one of the AWS conferences, I believe last year, with Chick-fil-A. And I didn't even know this before I saw the video, but apparently waffle fries is their most bought product. I would have assumed chicken nuggets or something else, but it's waffle fries. And it's such an important product for them that they needed to create a detection algorithm to let them know if any of the fries that they have out are not fresh anymore. So they wanted to optimize that. So they used one of our services, SageMaker, to calculate the freshness of the waffle fries. Really funny use case, but it's also really cool. So you can see over here that data scientists at Chick-fil-A trained their machine learning models to not only learn about fries, but also which ones were fresh fries and which ones were not. And you can't use image classification again for a problem like this because image classification would just tell you it sees fresh fries, not fresh fries. You want to know which specific boxes over here have the fries that you're looking for. Some other really popular use cases for detection are face detection. You see this used quite a bit in surveillance videos, counting as well. This is used for inventory management. I've definitely seen a lot of companies using detection for that. And then also, again, video surveillance that see anomalous objects in video scenes is really good for detection. And the last really big, I would say, computer vision algorithm is segmentation. So again, classification tells you what's in an image. Detection tells you not only what's in an image, but where in the image it's located. And now segmentation goes one level deeper, where it tells you not only where the image is located, where that object is located, but at the pixel value. So now it's no longer bounding boxes, it's the actual pixels that segmentation can show you about an object. And there's some key use cases that I've seen in my career for segmentation. One is graphics. You see a lot of companies, especially car companies, use image segmentation on their car photos, and they wipe out the backgrounds for other backgrounds in their advertisements. That was kind of an interesting use case the first time I saw that, but it's quite big. The other use case is autonomous driving. So it's very important to have accurate details of where each object is, not just bounding boxes for a general area, but up to that pixel level for secure driving. And then medical image segmentation is another really big one for segmentation. You want to know precisely where these elements are in an image, and segmentation can do that for you. So when I was preparing this talk, we have this really cool device called the Deep Lens. And I wanted to bring it over here to showcase it for you. However, I lost one of the wires for it. So I thought, let me take some time and code up a quick application to show you how Deep Lens is and how it works. But essentially with Deep Lens, you can create models in the cloud with AWS and deploy it on this edge device over here and actually have literally machine learning in the palm of your hands. So I don't have the Deep Lens with me, but I made a quick application to give you a sense of how Deep Lens works, and if you ever want to play around with it, you can order it on the AWS store as well. But let me go ahead and load up this application over here. So it's loading. Let me just go to it. I don't know if you can see it right now, but essentially right now, I'm running recognition, what I just showed you before, face detection on a video feed. That video feed is looking at my face, and it's running a lot of the recognition algorithms that it's seeing on my face. So you can see it says that I am aged between 29 to 45. It's changing based on my angles I'm moving right now. Smiling, false. I don't guess I'm not smiling. I don't have a mustache, beard, and I look calm right now. So that's a little bit of what recognition can do, and this is detection as well as face detection. So let me get out of this and go back into the presentation. All right. So I definitely recommend, if you really want to play around with a lot of these machine learning models, to check out the Deep Lens. It's really cool, a really interesting device. New models are being ported for it right now. I think the last model that was just created for it was a bird watching model. So if anyone has an interest in bird watching, you can basically face this camera outside your window and just look at birds. It's pretty interesting. And now the fun part, guys. What you've all been waiting for. Let's build a simple image classification algorithm. Okay, so this is a problem that I actually had to solve beforehand. I figured, why not just solve it with all of you guys? So in this image over here, you can see both of my parents. You can see the garage door of the house I grew up in. And my parents wanted to know, they always forget when they close the garage door. There are times where they just drive away and they just drive right back saying, did we close the garage door or not? And I figured, what better way to solve this for them than with you guys live, right? So let's make this application. So I'm going to get out of my PowerPoint presentation here. We're going to start from scratch. I'm going to log into their AWS console. All right, so let me start fresh over here. Let me just go back to. So this is the screen that you get into as soon as you log into AWS. You can see a couple of things if you're not familiar with this. So on the top bar over here, you can see different items, services that you can pin to the top if you use it quite often. I really like this feature. Basically, you just click on the pin, and then you can drag and drop any functionality or feature up to the top over there. I'm going to close that. You can also check out the services in this view down over here, where you can click on any service that you want. For now, I'm just going to go search first. I feel like that is the best way. So I'm just going to say Amazon SageMaker. Now, for those of you who are not familiar with Amazon SageMaker, it is our fully managed machine learning service. It lets us not only label the images, train the model, it also helps us deploy that model as well and make inferences on it. So we're going to start from scratch here, guys. You're going to see a bunch of things as soon as you log into the SageMaker screen. On the left-hand side, you're going to be able to see all of the different functionalities that SageMaker provides. The first section over here, you're going to see the overview, basically the different options SageMaker gives you in the order that you most likely need when you're creating your model. For this case, we're not going to be using that ground truth model, that ground truth functionality, because I already took a bunch of images of my parents' garage door open and took a bunch of images of my parents' garage door closed. So it's already labeled data for our image classification model, and I can show that to you. So I have a directory here. It's in the folder called C-Demo for collision demo, and I have a bunch of photos of closed garage doors, and I supplemented these with other garage door photos that I found too to make this model really accurate. So you can see over here a closed garage door, and I have ones open. So open garage door photos. And what we're going to do now is create an image classification model using these labeled images. And when I say labeled images, you're going to notice that basically I just have closed images in one directory called closed, open images in another directory called open. And essentially, when you create your own machine learning models, regardless of what tool you're using, this is how you label your images. And this is how most tools look at your images when they ingest it. So I have this directory closed or open. Now, I'm going to go ahead and open a notebook instance. The notebook instance is kind of our direct access to do all of our machine learning models. And SageMaker gives you a preset notebook that we're just going to follow that has a quick and easy way to do image classification. So I'm going to go ahead and click on Create Notebook Instance. And we're just going to give it a name here. We're going to call it Collision Demo Live. Over here, you're going to see an option saying Notebook Instance Type. You really want to make this, especially when you're learning SageMaker, the lowest option. There's no need to have a higher option for your SageMaker notebook instance because you're not doing any of the training or any of this compute happening on this notebook instance. This is going to be just a bare bones instance to run a notebook, which is just this method to run oral code to train a model. So basically create the lowest level instance and leave everything else default. And now we have our first, now it's going to start, you can see the status over here in this option, it's pending. So it's actually spinning up a virtual compute instance that's going to load up our machine learning notebook so we can train on it. Now that takes a couple of minutes, but due to the magic of me already preparing a demo for you guys, I have another instance already started up so we don't have to wait for that. So I'm going to click on this instance over here. I haven't done anything yet, it's just already ready to go. Getting started collection. So now we can go ahead and open up our Jupyter Notebook. And our Jupyter Notebook now is going to give us an option to use some examples. Let me make this a little bigger because I feel like this is small. So as soon as we open up the Jupyter Notebook, you can see that there's no files. We haven't done anything yet. Nothing is running. I'm going to click on the SageMaker Examples tab. Now, SageMaker comes with a bunch of great examples if you want to build your own machine learning models. The one we're going to be using today is going to call Transfer Learning, and we're calling it Transfer Learning High Level. So I want to go ahead and click Use on Transfer Learning High Level. And we're going to say, create a copy of this notebook, and let's start working on it. So when I first started playing with SageMaker, I didn't see an easy way to bring in my own photos, make my own data set, and create a model for that. So I'll show you what I mean. Right away when we open up this SageMaker notebook for transfer learning, by the way, transfer learning just means that taking advantage of an already pre-built model and just adding a couple of images on top of that to get your result. Otherwise, if we don't use transfer learning, you're going to require lots and lots and lots and lots of photos to build up your model. And transfer learning pretty much takes us there 80% of the way. So it's already learned on another model called ImageNet. And from here, that already did 80% of the work for us. Now the last 20%, it's going to be augmented with my images of the garages. The garages are open and closed. So this notebook is a really great walkthrough. You can read the introduction, telling you what it's doing right now, the prerequisites. It's already preset with another data set called Caltech 256 data set. We're not going to use that data set for this. We're going to use that garage image as I showed you of open or closed. So just ignore the Caltech 256 data set. From here, you're going to see some prerequisites where it's going to start loading up some SageMaker machinery. We're just going to go ahead and scroll down over here. And this is the area that we really need to change. Basically, SageMaker now needs our images of the garage, both open and closed. And it needs those images in a certain format. SageMaker is using a framework on the underlying aspect of it called MXNet by Apache. And so that framework requires these images to be in a certain file, .rec file. So we're going to go ahead and right now modify those images that I have to put it in the file SageMaker wants. And I have a little cheat sheet here. Basically, there's a image classification tutorial on MXNet. I will send all this information to everyone who requires it, who needs it. But it's a great way just to see how to prepare your data set. So I'm going to go to the directory of my images. So let me go to the tab here. This is the directory I have my images in. So you can see closed, open. These are the garage images. And then I'm going to follow these instructions for preparing our data set for SageMaker. So we're going to run this command over here. And I'll explain what it's doing in 1 second. But basically, it's saying that run this program, im2rec, which will convert these images, im, to the rec format that SageMaker wants. I'm going to put a Python here because it's a Python program. And this will go ahead and do that. From here, it's going to create it's going to create a list file for us that SageMaker requires. And then it has this parameter here asking for a train ratio. Train ratio means that when we create our network, our model, we have a certain percentage of our model meant for training. So 75% of our model is going to be used for training. And then we need some way to evaluate it, saying, did we actually train properly? And so we're going to set aside 25% of our images and use that for evaluation. So I'm going to change this ratio here to 75, which means that now 75% of our garage images are going to be used for training, 25% are going to be used for evaluating. And now we're going to go ahead and create a name for this file. So I'm going to call it cdemo. And we're going to say, create this on, I believe this needs to be done one level above. So let me just go ahead and copy this again. Sorry guys, I was in one folder below. Let me go ahead and go one folder up. And then from here, I'm going to go ahead and, 1 second. I'm just going to move up this program im2rec up one level above. So I'm going to say move im2rec one folder above. Go one folder above, and now we're going to make it happen. So I'm going to paste that command again, Python image to rec, and it's going to say call this new rec file cdemo, and then I'm going to say go to this directory, which is also cdemo, and enter. And now we can see that it actually processed that directory. It created 2 files for us. So we have cdemo train, which is our training images, and we have our validation images right here. Now I'm going to go back to this little prepared data set tool over here, and now we're going to create the second file that SageMaker wants us to create. So I'll explain what's going on in 1 second. So now what we're going to do is we're going to run this same program again, im to rec, to get that same format that SageMaker loves, that rec file. And all of image classification models, they always want your photos to be both the same width and height, right? It's really weird, but they always want it to be the same width and height. So this automatically does that for us. So right now it says 480 here. We're going to make it 224, just a little bit smaller. So the width and height of all of our images are going to be like that. We're going to give it quality 95, and now we're going to say run on 16 threads to make it happen pretty fast. And we're going to again say cdemo. Did not find any proof. Oh, can you not see? There we go. Is that better? Perfect. So now we're going to go ahead and let me do that again. We're going to make our second set of files that SageMaker loves, which is the REC files. So I'm just going to go ahead and copy this command, Python, and then we're going to say image2rec.py. From here, we're going to go ahead and resize our images into the format that SageMaker loves. So we're going to say 224 as the width and height of our images. Then we're going to set the quality. We're going to say 95 out of 100 quality, so still pretty good quality. And now we're going to say run on 16 threads. And then from here, we're going to say the name of this file should be cdemo, which is our directory where all our images are stored. And we're going to call the file name cdemo as well. So let's see if this worked. It didn't work last time. I'm not sure what I did wrong. Resize cdemo. What's that? Did I? Oh, I see what you did. We got a good audience. Thank you, sir. Did not find any file with the prefix cdemo. Let me just see what I'm doing wrong over here. I'm not sure, but I do know this. I do have all these files already set just in case if something like this happened. So I do have the files over here, myrec, lst. Not sure what happened over there, but we're going to go ahead and use those. So basically over here, we're going to switch over. We're going to take away, in this Python notebook, we're going to go ahead and remove any reference to Caltech 256. We're going to call this garage. And we're going to take away saying we're no longer going to download this weird data set from Caltech 256. We're going to download the garage images from my computer. And I have these images behind a URL I created just for this demo. So I'm going to put this URL over here. I'm going to replace it over here. And so our notebook can download these SageMaker files from my notebook. And I'm going to then put the training image over here. Pretty much just copying the images that SageMaker wants. So I'm going to click My Data Train, copy it over. And then we're going to do the same for the one right below. We're going to remove this and copy over the garage images that SageMaker wants. So I'm going to go ahead and put that same URL that's pointing to my computer right now. It's using a service called ngrok, which is just opening up my computer, and so you're able to access everything from there. Now I'm going to go ahead and just remove this file over here, the other garage image file that SageMaker wants, and use the one that I have, which is mydatavalidation.rec. Perfect. And now I'm going to just change these files to remove the Caltech one with the images I created. So we have replaced this with, replace this with the validation file, and then replace the train files with the train files. Okay, so pretty much what just happened here is we're just replacing Caltech 256 with our own data set that we created in the format mxnet-lex, which is these .rec files. Then from here, I'm just going to go ahead and remove Caltech 256 and just replace it again with our train files. And this is going to go ahead and use these images for our training. So I'm just modifying this right now. It's going to go ahead and use these images for our training. And that is it for our data set. Now comes the fun part, right? Now it's just training this network. This network now is going to go through all these images. It's going to see which ones are open, which ones are closed, and create an image classification model to help us do that. You're going to see a lot of parameters here. I'm not going to go through each one of these, but these specific parameters help to change the knobs that how our machine learning model trains. So really good descriptions of each of these. How deep do we want the machine learning network? Layers means how many of those artificial neurons do you want connected to each other, right? How many layers of those? So for here, we can just see all the different types of variables we can change. I'm not going to talk too much about those since this is an introduction class. And then from here, we can start the training. Now, training takes a little bit of time. It takes around 10 to 12 minutes. I don't feel like everyone here wants to wait 10 to 12 minutes. So I already have this trained again. Like this is like a live cooking show. I'm taking out a fresh pizza from the oven as if I just made it. So I already have this trained. We're going to go ahead to the pre-trained model. Let me just refresh my connection here. No. All right, let me go back to SageMaker and go to my notebook instances. I have it running right here. Let's go ahead and open it, pre-trained model. Okay, I'm going to go ahead and open this up. So now we have our other notebook instance that was already pre-trained. I already did this whole process of getting the rec files set up. Everything was already trained, and you can see this is where all the training happened. It gives you logs and other training jobs. And now you can see it took a picture of a garage door over here, which is the garage door my parents have. I'm going to use a different image just for this. So I have another image that I haven't used for training. We're going to check an open door garage and see, does it actually see if the garage door is open? So I'm going to click on this open over here that I've already stored in S3. I'm going to copy the link, and we're going to pass it to my model and see, does it look like an open garage? So let me just find this. Okay, let me give it the URL of my open garage. Now it has this. I'm going to go ahead and run this specific cell so it downloads that image. And now we're going to say, evaluate that image, run that image through our model. And on the bottom over here, you can see, let me go over here. I don't know if you guys can see this. You can see result label open probability 0.8561%. So using SageMaker and MXNet, we can go ahead and create a model that tells us whether our garage door is open or closed in this particular instance. Now, the cool part of this alone is okay, it's cool, but I think what's really cool with this is now if we now go ahead and attach it to a web camera and from there face the garage with that web camera and now notify my parents either through text message or some sort of a notification letting them know that the garage door is open or closed. And that's next plan of this project right now. So literally that's what we created. If you want to find out more info on this, let me go back to my slides. So if you want more information on this, you can go to check out the SageMaker documentation. If you already signed up for this talk, you're going to get these slides emailed to you, and also with all the other links that I use right now in this talk as well. Open to any questions from Twitch or the audience as well. Please feel free to ask anything. Yes?
Hold on one second.
Oh,
I'll
yeah,
bring the mic
we got to
to
get you the mic.
Hey, thank you very much. Like, let's say for someone that has a business idea in mind for AI, but doesn't necessarily know which model that would work for their application.
Yeah.
How would you go about starting the journey of finding the best model for your particular application? Like, let's say it's not as easy as machine vision. It requires like complex data sets like healthcare records.
Yeah.
Like something like that would exist, or is that something that you'd have to refine and create yourself?
Good question. So a couple of things. First, if you can avoid using AI, definitely avoid using AI because it needs so much data to make an accurate model and also generalize it in everywhere. You can find a lot of great data sets on the AWS Machine Learning Marketplace. Also, there's a lot of great data sets online as well for healthcare and other aspects, depending on your specific use case. Take advantage of those. There's also a lot of pre-made solutions already trained and pre-made models that are available as an API with services. I would also say check out those as well.
We've got one question from Twitch.
Go for it.
This is from Skull Crusher for Life, and I want to shout out to him or her for paying attention for so long. Thanks for tuning in. But they ask, how well does it handle a drastic change, say that the garage is closed, but there's a vehicle in the garage taking up 70% of the image?
Yeah, that's a good question. So right now in this particular model, I use no photos of if there's any sort of occlusions with garages in that image. So it's not going to work well. And that's the trick when it comes to creating your image classification models. You want to do something called generalize. You want to be able to make sure that your models can be generalized over many different instances where you personally would be able to recognize that's an open garage door or closed garage door. So you would need much more data to help it understand whether there's a car there and it's blocking it and it's still an open garage door or closed garage door.
One more question. How does it handle various lighting? Same similar situation, right?
Exactly. Yeah, the exact same situation over there. You would need to have a better data set to handle different lighting. In this particular use case, I try to look for different lighting in the garage, whether it's nighttime, daytime, and creating the open or closed garage door photos. Yeah. I believe we have one question here. Yes?
Does it cost money to use SageMaker, and up to how much can you do for free?
Yes, so there is a free tier as well. So the first couple of hours are free, and then there is pricing to train the models. For reference, for me training that model, I believe costed 38 cents when I was looking at the numbers for it. But depending on how you do, what type of machines you use, a lot of different factors can vary into that. Yes. Oh, wait, we need a mic.
How does the web service APIs that you would call outside of SageMaker compare to, I guess, the algorithms or functions that you're calling in SageMaker? Are they one and the same, or is, in SageMaker, would you need to call multiple functions that are maybe encapsulated in a single web service API?
So what was the first part of your question? Is it different compared to?
Yeah, well, so there's photo recognition or vision recognition web service APIs that AWS offers, and you don't need to go through SageMaker to call those.
Yeah.
How does that compare to going through SageMaker to do the same thing? Like, do you need additional calls? I understand the value of being able to train through SageMaker, which you wouldn't be able to do through a web service API. Could you kind of explain what the distinction between the two would be?
Yes, so the web service APIs like recognition are already pre-trained models trained by large data sets with our AWS data scientists on there. With SageMaker now, you are customizing, not those models, but you're building your own with your own data sets for your own custom solutions. So those models that are in recognition don't solve every use case, right? There's no garage door open, garage door closed, particular web service API. You would need to build something like that yourself, and SageMaker is a tool to do that.
Hi. Are the training photos that you use to train these, are they all available? Can we, I've been trying to use AWS to do image recognition for certain things, and I'm trying to get it to pull out certain things from a poster, but I keep just getting that the poster is a poster. So I was hoping to take that out and then retrain with the exact same data set, though, because it's otherwise quite good.
So can you repeat the part about the data set again?
The photo data set. So the training set that you used for training all of the models that you have pre-trained in AWS. Can we use that data set, the photos that you used to train, except smaller subsets of it in order to retrain, or do we need to go get all of our own photos all over again?
Right. I would say get new photos on there. So those photos, I use 75% of those photos for training, another 25% for validation. Now, if we did want to add more photos for training, we could take out from the validation set because it wasn't used for training, but then we'd have less to validate how well our model did. So essentially, it's basically saying retraining this model, but instead of 75-25 split, you can do maybe 95% of those photos trained, 5% for evaluation. But that's about it. You can't retrain again with the same photos that you've already trained with. I mean, technically you can, but then it goes into overfitting where now it can't really generalize well in other models.
Sorry. Can we access the photos used to originally train these pre-trained models?
Yes. Yes.
Okay.
Those photos you own, you have, and then you can put those photos there as well.
Okay.
Yeah.
Hi, I have a question about integration, but with another device. I was thinking about doing something with computer vision, but using drone. How it's possible to integrate it with AWS?
So your question is how to take advantage of a drone with image classification as well?
Yeah.
You would have to get access to the footage of that camera somehow, train a model with it, and then from there be able to take certain actions with your drone from that footage.
And just to add on to that, we
Yeah.
have a service called AWS IoT Greengrass that allows you to take these trained models and deploy them to edge devices like you would have on the drone, and that's how the deep lens works.
Hi. For instance, if you train the model with 1,000 images, right? And then if you,
Sorry, can you speak up again?
for instance, if you wanna train your model with 1,000 images,
Yeah.
for maybe the open and door close, and if you want to add more to improve the model, like you have to train again like 1,100, or you could add just 100 to the model.
Oh, you're saying, yeah, if you want to now retrain that model again
Yeah.
with more images, is
More.
there's a specific number for efficiency?
Yeah, I mean, should I retrain the previous 1,000 images as well, or just the 100 images adding to the existing model?
So it's already been trained on those previous images. I would
Yeah.
recommend just using new images for the future training.
So it's
and
still
everything.
good.
Yeah,
Okay.
yeah.
Okay.
Yeah.
Makes sense.
We've got another Twitch question from Rampage Wildcard, who's asking if you were going to start from scratch, what is a size of the data set that you would want to use? And I think that depends on if you're using one of these existing data sets and doing transfer learning, or if you're really starting from scratch.
Yeah,
right?
yeah. So if you're starting from scratch, we kind of call it training it by pixels. It really depends on what your categories are and what you're trying to train for. If some things are very similar, you're going to need tons of images. And I'm talking like thousands and thousands and thousands of images to differentiate between two different similar types of classes. If they're wildly different, you're going to need less images, but we're still talking about quite a bit to train those models. I've never seen it done less than 1,000, but that's from my experience.
So after you train the model, can you export the model somewhere else, or is it stuck on Amazon?
No, you can totally export it somewhere else, wherever you want to. You also have the ability to quantize that model, so it can also run on edge devices like Brandon mentioned over there too. Awesome, guys. Unless there's no more questions.
Yeah, I think that's about it.
Perfect. Well, I hope you enjoyed Collision. So glad that you came to my last talk. Thank you, guys.